Okay, in this video lesson, we will be doing this example where we solve for all values of x by factoring. Basically, what we are doing is we are solving a quadratic equation. So here's our equation, x squared minus 15x plus 56. This equation is already in standard form, ax squared plus bx plus c, okay? So in order to solve this quadratic equation by factoring, we're going to do exactly that. We need to factor. Okay, so remember that we learned to use the x game, okay, in order to factor. So if we were to do the x game, remember we're finding the factors of a times c that equal b, all right? Well, in this example, a is 1, okay? So we have 1 times 56. So we're finding the factors of 56 that equal b, which is negative 15. Negative 15, okay? So the factors of 56 that equal negative 15 are going to be 8 times 7, okay? 8 times 7 equals 56, but we need it to equal a positive 56 when they're multiplied, but if when they're added or the sum is a negative number. Well, if they're combined to equal a negative, but they multiplied to get a positive, then they're both going to have to be negative, okay? So then we're going to have an 8 and a 7, okay? And again, when a is equal to 1 and you factor it, it's as simple as x plus this number and x plus this number, or these are both positive. So when we factor this original, our factors are going to be x plus 8 times x plus 7. All right. Now, in order to solve for all values of x, okay, we're going to take each one of these binomials and set it equal to 0, okay? So the solving part takes the x plus 8 and sets it equal to 0, and takes the x plus 7 and set it equal to 0. Well, basically you're subtracting 8 from both sides in the first one, so x equals 8. Or you simply know that that should be negative 8. 0 minus 8 is negative 8. So that's my mistake there. That's a negative 8. Okay. Let me go ahead and erase that and write that correctly. All right. That's going to be x equals negative 8. And we know that real simple because negative 8 plus 8 equals 0. Here, if x plus 7 equals 0, then it's going to be negative 7. Okay. Or basically, again, what we're doing is subtracting 7 from both sides, and x equals negative 7, okay? So that will be your answer. X equals 8 and x equals negative 7. Now, let me give you another example because this one's a little bit unique, okay? You'll notice here, first of all, it's not written in standard form. This is an equation, but we have variables on both sides. So we're going to need to combine the x's and combine the constants. Well, we have our ax squared, okay, and there's not another x squared. But we're going to need to move this 3x. And remember, to move a 3x, we're going to move it to the other side. It's going to become the opposite. Okay, that's one way to think of it. Move it to the other side, and it becomes negative 3x. And then it gets canceled over here. And then this plus 1 is going to become minus 1, and it gets canceled over here. So on the left side, we just have, on the right side, we just have 0. Well, now on the left side, we can just bring down our x squared. All right, but then we have a 3x minus 3x. Well, that's 0x. So we're not going to write 0x, okay? But over here we have negative 24 minus 1, and negative 24 minus 1 is negative 25 or minus 25. So now what you're factoring is x squared minus 25x equals 0. Well, if you remember, this is the difference of two squares. The square root of x squared is x, and the square root of 25 is 5. So if we know that, then we can add them one time and we subtract them one time. X plus 5, x minus 5, and we set that equal to 0. Well, if we're trying to solve this quadratic equation, then we set each one of these binomials to set it equal to 0. So x plus 5 equals 0, and x minus 5 equals 0. Well, the answer here is going to be negative 5, because we would subtract 5 from both sides. Over here, we would have to add 5 to both sides. Or if that's complicated, you just know that negative 5 plus 5 equals 0, and positive 5 minus 5 equals 0. So again, your answers are 5 and, or negative 5 and 5. All right, so that's a look at solving quadratic equations when a is equal to 1.